project, we basically interface two Arduinos. We use their sensor from Project 3, which basically takes your pulse from your finger, and we got it to output it to a display cube, two-dimensional. So basically what this project is supposed to do is it's supposed to translate your BPM reading from the sensor, and it's supposed to output it kind of like an EKG waveform onto this cube. The only difference is that instead of displaying the typical EKG form that you guys normally see, it simulates your heartbeat with an actual beating heart. So it constantly outputs a calculated BPM, which keeps refreshing onto a beating heart, which is basically onto the cube. And it should be able to accurately measure your BPMs pretty consistently. So the way it works is that we have a sensor hooked up to one Arduino, which basically outputs a rate onto a second Arduino. So we just have one pin connected between our Arduinos, and the second Arduino is used to control the cube, which works by using multiplexing and has 8 different ground layers, 64 different pins. So that's 512 LEDs that we're using. Or that's the one cube.
So this is a design overview, just kind of the stuff we used in making this. For the hardware, we used a typical pulse sensor, just got it from SmartFun. The same pulse sensor we used in Project 3. We used 2 Arduinos, one to control the cube, because we had a lot of LEDs, we had to devote a whole Arduino to it. And we used an original Arduino, just like we used in Project 3, to interface with the sensor and do all the calculations responsible and work with our LED screen as the output for that as well. And then of course we used an LED cube as a visual display to show the calculated BPM. For our software design, we use kind of a linear walkthrough model where we detect the pulse from the sensor from the human user, and we use an interrupt with the first Arduino to detect that. We translate that to a BPM through calculations, math, and such, and then we translate that to a rate also that we can give to the second Arduino, which will send a pulsing update to the LED cube so that it's all in chain parallel together. And for integration and testing, a lot of our original testing with the sensor was done in Project 3. We added a whole new piece of hardware that we had to integrate into that and test. We tested over various inputs because we had all of us testing, and we all have different BPMs, obviously. And so we had to use that information to calibrate it using different software and calculations. And we do meet all of the requirements and specifications that we outlined in our original proposal. So now we have a demonstration for you. So you can see we have the heart shape showing up on the cube. Ari here is detecting, he's using the pulse sensor up to his thumb to detect the pulse. And it takes a little while to gather the information and read it in. Then it'll read it into the original Arduino, which will do calculations. And you can see it's outputting kind of a pulsing motion. This is
pretty fast heartbeat.
Yeah.
This is a heart.
So this is a pretty fast heartbeat. One caveat about the sensor is that you can't make medical equipment for $30 that is safe, consistent, and reliable. So this is the best we can do with the technology and the budget we have. So right now the LCD is saying that I have a BPM of about 60 something, 67, and so we are actually outputting a reasonable heartbeat right now.
67 is it's about human.
And the reasonable values for a human heartbeat is anywhere between 60 and 100. 40 is considered flatlining, and anything above that, you're probably having a stroke.
We've also noticed that after running the sensor for more than a minute, really, just with the light on, that the readings will become more and more sporadic. They'll jump around a lot. For instance, when we first turn it on, they start up in the hundreds, which is why it was a solid heart, because it was technically just flashing really fast. And once it drops down to reasonable rates, it was just in the 60s. Obviously you can see the heart flashing normally.
Mm-hmm. So it does take a little while for the sensor to zero in on a
correct range.
Right.
And it samples every once in a while. This thing updates. So yeah, it's a project. It's a project question.
Another human subject.
Yeah.
Does someone want to test it? Mickey, do you want to?
We need you to sign something.
Sure.
Just hold your thumb firmly on it.
Go ahead and reset it.
What are we reading?
It's a healthy
What
specimen
are we
right
reading?
here.
We're reading your patience.
You jump the guys.
Okay. So the way this one works is it outputs an LED light, transmits it, and then it reads it back based on your blood flow, which is not a typical heartbeat sensor, but it works.
The light basically just detects the pulse of the blood flow. And it's actually not getting a reading for him, which I noticed it actually does the same thing for me.
I'm dead, aren't I?
I mean, I'm dead as well, I guess, but for some reason Ari's hands seem to work much better.
Got that touch.
That you just read the whole thing.
And now we have a reading again.
He's alive.
It's because of the head.
Be consistent. Oh, no, it wasn't.
So there you go.
Good. Sweet.